Hey, welcome to October 21 Pure Free examination. Right there. Just a side note, this solution has been created by myself and my class. Look, we're having breakthroughs right now. If there's any mistakes, let's blame it on them. Thank you. Okay, question 1. Nice and simple by the looks of it. So, part A, show that fx equals 5x plus 3. Okay, so we have addition of two fractions. We know when we add two fractions, we need a common denominator, don't we? So, first thing I'm going to do is factorise this and then see what I need to multiply both sides by. So, for part A, I'm going to get 5x over x plus 4, x plus 3. Okay, so it's really nice that it's factorised to this. That means I know that I need to multiply this by x plus 3 over x plus 3. So I'm just going to get ahead and do that straight away. So I'm going to have 5x squared plus 15x over x plus 4, x plus 3. So then this is going to give me 5x squared plus 20x over x plus 4, x plus 3. Now I see I have factors on the numerator, yeah? 5 and x. So I'm going to take out 5x, bracket x plus 4, over x plus 4, x plus 3. The x plus 4 is going to cancel, so I'm going to get 5 over x, x plus 3. Okay, therefore proved. Nice, easy 3 marks. Okay, part B, find the inverse of f. Now, I actually haven't seen a question like this on the Pure Free before. Last time I've seen a question like this is literally a GCSE question. It's on the IGCSE, yeah? It should be really easy. So for part B, if you've got, so I'm just going to do y equals 5x over x plus 3, rearrange. So yx plus 3y equals 5x. I've just multiplied that, yeah? I'm going to move my x's on one side, everything else on the other. So yx minus 5x equals negative 3y. Now I'm going to substitute, factor x, aren't I? X equals y minus 5 equals minus 3y. Divide both sides. Minus 3y over y minus 5. Now what I am going to do is rewrite that as f of the inverse of x and then substitute x's where there's y's in. Some people do this different, however is easier. So minus 3x over x minus 5. Okay? Some of you might have positive 3x, 5 minus x. That's okay. It's the same. Right? Then part C, so that's another 3 marks. Part C then says differentiate f of x. So we're going back to the original one. Okay, differentiate f of x. So we do that over here. B. Right, here we go. Right, f of x equals 5x over x plus 3. Okay. I need to differentiate this. Bye. Okay. What do I have? Quotient rule. Yeah? So V is on the bottom. Who's on top? Yeah, you are on top. And we know the quotient rule is V du minus U dV over V squared. So what I'm going to have is I know what my V and U are. I'm just going to write du, which is 5, differential of U, and the differential of V is 1. Okay, so it's really simple. So now, V, x plus 3 times 5. 5x plus 15. Minus U, 5x, multiplied by dV, it's just 5x, over x plus 3 squared is actually going to give me 15 over x plus 3 all squared. Nice and simple, okay? Really easy to differentiate. Now, it also says Hence, state whether f is an increasing or decreasing function given a reason for your answer. Okay, it's increasing if the gradient is positive. Okay? Now, what do we know about square? First of all, 15 is positive. Okay, this is greater than or equal to 0. Square number is always greater than or equal to 0. Yeah? Therefore, positive divide positive must be greater than 0. It's positive, isn't it? So we have positive gradient, therefore increasing function. Okay, now we don't have a mark scheme, so I have no idea exactly what they're looking for, but if we get something like this, we're on the right lines. Brilliant. I have to give up. Okay, question 2. This was a nice, easy question. It says, state the coordinates of P. Now, if we think about this, this is like in completed square form. Okay, so if we want to find the turning point, we just solve the modulus equals to 0. Okay, when the modulus equals 0, what does x equal? 13 over 3. And then obviously our y coordinate is 5. Okay, state the range of f. This is saying range is our output values, our y. Now, by looking at the graph, we know that y is always greater than or equal to this minimum point here, isn't it? So we would write the range of f is that f of x is greater than or equal to 5. Okay? Because that's our minimum value. Then it says find the value of ff4. Okay? So I'm just going to do this over here. F of 4 to begin with equals 3. What? That is a crazy 3. I don't know what happened there. 3 times 4 minus 13 plus 5. Okay, 3 times 4, 12. Minus 13? Minus 1. Okay, remember, we're going to take the positive plus 5. So this actually becomes 6. Okay, so now we do f of 6. Okay, which equals 6 times 3. 18 minus 13 is 5, which is positive anyway, plus 5, 10. So this equals 10. Okay, then, here we go. Part C, solve using algebra and showing you're working. I'm just going to write it over here. 16 minus 2x is greater than the modulus of 3x minus 13 plus 5. Okay, remember, when we solve this, there's 2 ways. Okay, because we have a modulus, we're going to take the modulus as it is. So 16 minus 2x is greater than 3x minus 13 plus 5. Or 16 minus 2x is greater than, and then I multiply what's inside the modulus by negative 1. Minus 3x plus 13 plus 5. Everyone happy? Yeah? Okay, so I'm just going to do this quickly, guys. I'm going to add minus 13 plus 5 is negative 8. 16 plus negative 8 is 24. Is greater than 5x. 24 over 5 is greater than x. For that other one, 18 minus 16 is 2, minus 2x plus 3x is x. Okay, I've just rearranged it quickly. Now, if you left it like this, you wouldn't get the full marks, I don't think. Because if you think about it, this is saying that x is smaller than this, but x is bigger than this. Straight away, what do I see? X is in between 2 and 24 over 5. Because I know 24 over 5 is 4.8. Okay? Okay, so that's that one. Then, now part D, I did this in my head. Let's see how to explain it. Okay? So let's think about this. The new coordinate is now 420, and before we had 13 over 3, 5. Now I look at A. Okay, A is outside the bracket. Who does it affect? Y. What do I do to all my Y values? I multiply. How did I get from 5 to 20? I multiplied by 4. So, oh, yeah. So A equals 4. Yeah, I multiplied by 8. I thought you said 8. Okay, so A is 4. Okay, then for B, if I think about this, B, we're adding B. Okay? So we do the opposite, don't we? Yeah. We take away. So 13 over 3, take away what is 4? It's a third, isn't it? Because 4 is 12 over 3. So that means B is a third. Nice and simple. Right, so question 3. The total mass of gold, blah, 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 where T is the number of years after the 1st of January, 1800s. Figure 2 shows a sketch. Use the equation of the model to answer parts A, B, and C. Hence, find the value of K. Okay, how are we going to find the value of K? Well, we need to put this equal to 0, don't we? So to find the value of K is on the x-axis, so we need to find where it equals 0. So when y is 0, or g in this case is 0, so 0 equals 40 minus 30e to the 1 minus 0.5t. Yeah? So I'm going to rearrange this to get 30e, 1 minus 0.05t equals 40. E to the 1 minus 0.05t equals 40 over 30, which is 4 over 3. Yeah, ln both sides. So I get ln of E to the 1 minus 0.05t equals ln of 4 over 3. Okay? We know that these are going to cancel, so I'm going to have 1 minus 0.05t equals ln of 4 over 3. I'm going to take away 1 from both sides. So minus 0.05t equals ln 4 over 3 minus 1. Divide both sides by minus 0.05, and then this leaves me t. Now, it gives me t, but that's in fact k, isn't it? Then, when I actually put this into my calculator, I get 14.25. Okay, it's approximately this. So it didn't say in the question to leave it exact or anything, so we can leave it like that. Part II says, hence find the year and month in which gold started being extracted from the mine. So if we started on the 1st of January 1800, add 14 is 1814. Now we've got 0.25. How many months are there in a year? 12. So if I multiply this by 12, the third month. January, February, March. This is going to be 1814, March. Okay? Nice and simple. Right, so now part B says find the total mass of gold extracted.
I don't think that's the logic.
So if we think about it, 1800 to 1870 is a full 70 years. So T is 70. So we're going to have G equals 40 minus 30e to the power of 1 minus 0.570, which is going to give me 37.54. So the limit, as t tends to infinity, G is going to tend to 40. Because the bigger this gets, the closer this gets to 0. Minus 30 times 0. 0, 40. Someone's got an answer for that. Okay, so question 4. Show the equation can be written in this form. Okay, the first thing I'm seeing, I see this, I'm thinking sine A plus B. Well, in this case, sine A minus B. So I'm going to have two lots of, and this is my A and this is my B, and this is in the formula. And I get two lots of sine A.
Put minuses everywhere.
So this is then cos 30 minus 2 sine 30 cos theta. Okay, now, a lot of people always get stuck on this part. First of all, if we've been given cos 30s, we'll be able to figure this out. Okay? So, cos 30 is root 3 over 2. So I'm going to have 2 sine theta root 3 over 2 minus, and then sine 30 is in fact a half. So this is 2 lots of a half cos theta. Okay, and this equals 5 cos theta. So what I'm actually going to have is root 3 sine theta minus cos theta equals 5 cos theta. So then I get root 3 sine theta equals 6 cos theta. I know tan is silly cow, so I'm going to divide both sides by cos and by root 3. So I'm going to have sine theta over cos theta equals 6 over root 3, which is tan theta, and then what they've done is they've rationalised the denominator. So I'm going to get 6 root 3 over 3, which is 2 root 3. Therefore, proved. So, for the second part of the question, what we need to look here is you can see theta minus, you see here, theta equals x plus 20. Okay? So, and theta minus 20 equals x minus 10. But what we find is that because theta is x plus 20, that means if I was to put x plus 20 in here, x plus 20 minus 30 is x minus 10. So theta is definitely x plus 20. So I'm going to substitute x plus 20 here. My theta. Yeah? So for part B, I'm going to have tan of x plus 20 equals 2 root 3. And I want to do this between 0x and 360. Yeah? So, now what I'm going to do, change my interval. X plus 20. X plus 20 is less than or equal to 3, 80, and 20. Okay? Then, so x plus 20 equals shift tan 2 root 3. I get 73.89 degrees. I'm going to draw my CAS diagram. Okay, this is 73.89. Now in this case, our boundaries aren't going to affect it. This plus 20 means we start at 20, which is here, and finish at 380, which is also then here. This is 20 degrees. So in this case, it doesn't affect it, but it's always good. Tan is a complete reflection, so this is 73.89. Okay, so I start at 0. First one I cross is 73.89. This is 180 plus. So that means I'm going to have 253.89. Yeah, because this is 180 and I'm going to add that. If you do 270 minus, you've got to do 270 minus this angle. Think of it as like a drawing. You're measuring from 0 all the way around to this angle. Yeah? We did 270 minus. We do 270 minus like 16. Because this bit is 16. Yeah? If you know this angle and you know this is 90, if you want to do 270 minus, you've got to work out the other angle. It's literally a drawing. Okay? So now we have x plus 20 exists. How do I find x? I minus 20 from everything, so I get 53 point, it wants 1 decimal place, 9 degrees, and 220, no, to 33.9 degrees. That's the final answer for that. Okay, so for question 5, part I, what are we going to assume?
y is equal to 2x to the minus 3 bracket minus 2.
Okay.
Power minus 2.
We're going to equal 2x minus 3 to the power of minus 2. That's because when we differentiate this, we're going to bring the power down, take away 1 from the power, which gives us minus 3, and then we're going to multiply by the differential of the bracket. If we differentiate the bracket, we get 2. So this equals negative 4 over 2x minus 3 to the power of minus 3. However, what do we want? 8. So what do I need to multiply this by?
Negative 2.
Negative 2. So that means my original assumption needs to be negative 2 lots of this, yeah? So therefore, we now need to find between 4 and 2, negative 2 lots of 2x minus 3 to the power of minus 2. Okay? So I'm going to substitute 4 in. So if I substitute in 4, I'm going to get minus 2 over 8 minus 3 squared minus 2 over 4 minus 3 all squared. Okay? So minus 2 over 5 squared is minus 2 over 25. Then this is going to be plus 4 minus 3 squared is 1. So this is going to be plus 2. Minus 2 over 25 plus 2 gives me... that's a negative, not a point. 1.92. Now, we can actually check this in our calculators using the integral function if we wanted, and we should get 1.92 as well. Okay? So I'll show you now. Okay, so you can see here, you can substitute this in. This isn't going to give you any more any marks. However, you now know that 1.92, you know you've done it right. So it's like you can guarantee yourself those marks, which is perfect. Okay, and then part II. It's like saying II, Captain. Find in its simplest form the integral of x squared plus 3 to the power of 7 with respect to x. Okay, so this time what are we going to assume?
X squared plus 3 to the power of 8.
To the power of 8. If we differentiate this, we're going to get 8 bracket x squared plus 3 to the power of 7 multiplied by the differential of the bracket. If we differentiate x squared plus 3, we get 2x. So I actually get 16x bracket x squared plus 3 to the 7. Now if I compare, I actually want 1x, not 16. So what do I need to do to my assumption? Divide by 16. So my answer is y equals 1 over 16 bracket x squared plus 3 to the power of a, and we have to write plus c. Perfect. Nice, easy 2 marks. To be honest though, I can't believe that was just 2 marks. Brilliant. Okay, question 6i. Here we have an equation. It says show that C1 has a stationary point at x equals this. So we need to differentiate, put it equal to 0 and find x, because we know that's how we're going to get a stationary point. Now, when I differentiate 3 ln, I'm going to differentiate it up here. So dy by dx. If I differentiate 3 ln x squared minus 5, I get 3 over x squared minus 5, and then I need to multiply it by the differential of the bracket. Minus 4x squared differentiated, bring the power down, decrease 1 from the power. So my differential becomes 6x over x squared minus 5 minus 8x. Now I'm going to put this equal to 0 and solve this to find, so ax equals 6x over x squared minus 5. If I multiply by x squared minus 5, I'm going to get 8x cubed minus 40x equals 6x. Ax cubed minus 46x equals 0. X bracket 8x squared minus 46 equals 0. So we have a solution x equals 0, or x equals 46 over 8 square rooted, plus or minus 46 over root 8 square rooted is... Yeah, you just put that into your calculator. We can rationalise it's 2 root 2. Root 23 over 2. Yeah, plus or minus. However, in the question it says x is greater than root 5, so p equals 23. Okay, so therefore, proved. Okay, then part II is a different question entirely. So there's a different curve, C2 has this equation. Show that this curve, dy by dx, is a plus b sine 2x. Okay, so let's differentiate this, yeah? So if y equals 4x minus 12 sine x squared. It's easier to write it in this form when we differentiate it. Dy by dx is 4. Okay, differentiate the bracket, bring the power down, 12 times 2, and then times the bracket, times the differential of the bracket. Now if we times by cos, it's then going to become multiplied by cos x. Okay? Sine differentiates to cos. Brilliant. So that's, everyone's happy with this. Okay. Now the next part of the question says, show it equals a plus b sine 2x. So, sine 2x, using the formula, is sine 2x equals 2 sine x cos x. Okay? Now, we have 24, so this is going to have to be minus 12 lots of 2 sine x cos x. That's going to then, we're going to have minus 12 lots of sine of 2x. So I get dy by dx equals 4 minus 12 lots of sine of 2x. Now, it says plus here, so b could be negative 12. I'm just checking we did this right. Multiply by this. Yeah. Okay, so this is part A. Nice and simple. Part B. Hence state the maximum gradient for this curve. Okay, so think about the maximum gradient of this curve. First thing I'm going to do is I'm just going to draw sine of 2x. Forget about the 4 minus 12. This is just a transformation of the actual curve, right? So if we draw sine of 2x. Okay, it's going to be the sine graph, but we're going to just half it, aren't we? Okay? It's terrible drawing. Okay, here we go. We know that this is pi over 2, negative pi over 2. But anyway, look, the maximum gradient is obviously the most positive gradient, right? The most positive gradient is in between these two values. If you think here, the gradient's 0, and then it changes, and it goes up and up. Then it stays at a constant gradient until it slowly gets closer to 0. But actually, where is this constant? Probably crossing through here, the point of symmetry. It's going to be the maximum. My x-coordinate here is 0. So I'm going to substitute in 0 into my differential equation. So dy by dx equals 4 minus 12 lots of sine 2 lots of 0. Sine of 0 is in fact 0. So therefore my maximum gradient is 4. Okay, the mass of a species can be modelled by this equation where r is the base of the radius, according to the model, find the mass of the tree, give your answer to 2. Okay, so I'm just going to substitute in 45 as r. Okay, so for part A, I'm going to get log 10 to the m equals 1.93 log 10 to the 45 plus 0.684. If I just put that into my calculator, I'm going to get log 10 to the m equals 3.874. This then means that 10 to the power 3.874. This is ... kept it as answer in my calculator, equals m. So that means that m equals 7493.7 ... two significant figures. M equals 7,500 kilograms. So that's done. It says show that the equation of the model can be written in the form m equals PRQ. So m equals PRQ. If you're not sure what goes with what, let's log everything. So I'm going to get log to the base 10 of m equals log to the base 10 of PRQ. Now we know log laws, that means multiply. So log 10m equals log 10p plus log 10r to the power of q, but we know that can then be written as q log 10r. I'm now going to match that up with what's happening. Log 10m matches with log 10m. 1.93 log 10r, 1 is q log 10r, so that must mean q equals 1.93. And then we can see from here that 0.684 must equal log 10 of p. So log 10 of p equals 0.684. So 10 to the power of 0.684 equals p. So p equals 4.83. Nice and simple. Great work. Okay, still slightly confused with part C. If anyone has an answer, comment on the thing. Question 8. So, question 8. I love these types of questions because you always have to use the same formula. Whenever you see anything like this, okay, always write down sine squared plus cos squared equals 1. It'll help you.
If I do this question right now.
Okay. Okay, so now we have f of x equals arc sine half x. Sketch C. This is literally worth 1 mark. First of all, when we're sketching, okay, if you think about the sine graph, looks like this. Okay. When we're doing the inverse, we need to reflect it in this line. Okay. It's only from certain points. It actually is now going to look like this. This is between 2 and minus 2, pi over 2, negative pi over 2, and make sure you write x and y. You'll get full marks for drawing that. It's beautiful, actually. It's probably the best drawing I ever had. Okay, the next part. This is what is exciting. B. Given that x equals 2 sine y. Okay? Let's do it together then. Okay, let's differentiate this. So, dx by dy equals 2 cos y. So, dy by dx equals 1 over 2 cos y.
Yes.
Okay. What fact do we know? Sine squared plus cos squared equals 1. So cos equals square root 1 minus sine squared. What does sine squared equal? X over 2. Squared. So I rearrange this. Yeah? So now we're going to have 1 over 2 root 1 minus x squared over 4. Okay. Now this is the part, because it wants it in the form, root a minus x squared. Right, so here we go. So, 1 over root 4 times root 1 minus x squared over 4. Yeah? What is root 4? 2. Using the laws of surds, this is the same as the square root of 4 bracket 1 minus x squared over 4. Which equals 1 over the square root of 4 minus x squared. So our A is in fact 4. Okay? Right. Part C. The point P lies on C and has y coordinate pi over 4. So to find x, I'm going to substitute it in here, right? So x equals 2 sine pi over 4. 2 sine pi over 4 is root 2. So x equals root 2. So our coordinate is root 2 pi over 4.
Is that a mark?
Okay? I don't know if it's a mark. It might be. Yeah, I think it will be. And then to find our gradient, I need to substitute in here. So my gradient, m, equals 1 over the square root of 4 minus root 2 squared. So my gradient is in fact 1 over root 2. Okay? So now, y equals mx plus c, pi over 4 equals mx plus c. So c equals minus 1. What's root 2 over root 2?
It's 1?
Yeah.
Oh, my bad. Okay, so like...
Pi over 4 minus 1. Okay? So therefore, y equals m x plus c. Okay? Okay, question 9. Okay, so here we have a few different equations, figures, etc. Right, it says figure 3 shows a sketch of part of the curve with the equation y equals fx, where fx equals this. Part A is find the differential. Okay, so we have product rule, but it looks like a product rule that's been done 3 times. So I'm going to just change this to x cubed minus 4x multiplied by e to the minus a half x. Now I have my v and my u for my product rule for differentiation. Okay, so v du plus u dv. So let's do this. So what is my v? X cubed minus 4x multiplied by the differential of u. If I differentiate e to the minus a half x, I get minus a half e to the minus a half x because we multiplied by the differential of the bracket. Okay, and then u dv is plus e to the minus a half x, multiply that by the differential of v. If I differentiate this, I get 3x squared minus 4. Okay, so this is f dash of x. So that was a nice easy 2 marks. Perfect. Now, here we go. The next part says something about the line L is the normal to the curve at 0 and meets the curve again at the point P, okay? The point P lies in the 3rd quadrant as shown in figure 3. This means we have a negative x and negative y, okay? Show that the x-coordinate of P is a solution to this equation. Well, first of all, how do we do that? We know that P intersects them both, okay? First, though, we need to find out what the gradient is because it says the point P is also on the line L, which is normal. So we know this is the gradient function. We're going to substitute in 0 to find the gradient of this curve and then do the negative reciprocal for the normal, right? So if I substitute in 0, f dash of 0 equals minus a half e to the minus a half lots of 0, which is 1, times 0 cubed minus 4 lots of 0, which is 0. So this becomes 0. Plus e to the minus a half lots of 0, and e to the 0 is 1, times 3 times 0, which is 0, minus 4. Is that right?
So it's just minus 4.
Yeah, so the gradient is minus 4.
Yeah.
So the gradient at 0 is minus 4. Okay, so the normal to this is?
1 over 4.
A quarter. Brilliant. So the equation of the normal is y equals a quarter x. And because it passes through the origin, plus c is just 0. So now, to find the coordinates of p, we can see simultaneous equations. So I'm going to get a quarter x equals x squared minus, x bracket x squared minus 4 bracket e to the minus a half x. Okay? Now, I need to rearrange this to get it into this form here, to show that the x coordinate, so we need to rearrange this now to get this. So let's go for that. So here we go. Can we divide everything by x?
Yeah, but why would you want to do that? You want x equals, no?
Yes, but we're going to get the x equals from here. Okay? So I'm going to get a quarter equals x squared e to the minus a half x minus 4e to the minus a half x. Okay? Now we have to be a bit careful because here I have e to the half x. So we need to try and get to this, don't we? Okay, this is our little thing. I multiply everything by 4. Okay? So 1 equals x squared e to the minus a half x minus 16e to the minus a half x. It's looking good now. Okay. Now, if I...
Doesn't this change to 4?
Yep, this becomes a 4. Okay, so now I'm going to get 1 plus 16e to the minus a half x equals 4x squared e to the minus a half x. If I move the 16 to the other side. Okay, I'm going to divide everything by e to the minus a half x. So 1 over e to the minus a half x. This is going to give us a positive.
So isn't that just
e to the half x, yes. So this is e to the half x. 16 e to the half x divided by e to the half x is going to cancel. Plus 16 equals, and e to the, if we divide that, we're going to get 4x squared. Plus 16 equals 4x squared. Now I'm going to divide everything by 4.
Shouldn't you limit both sides first?
No, we're not going to lin anything because there's no lin in this equation. Okay, so I'm going to get e to the half x over 4 plus 16 over 4 equals x squared. So now we're square root. Square root of e to the half x over 4 plus 4. Okay, plus or minus. X equals this. Right? Now, with the 4s, we can rearrange that again to x equals plus or minus square root of e to the half x plus 16. If we multiply everything aside, the root by 4, it's the same. Brilliant. Okay, we get to this. However...
You reject the positive?
we have 16 plus e to the half x. Check. We're going to reject the positive, but where does this minus a half come from? Okay, I've spotted how they've done this. Very, very cheeky. Okay, we got to this stage, right? Oh, see, this is great why we get to do it. We got to this stage. 4x squared can be written as 2x all squared. Here, from this. Scrap what I did here. I should have never divided by 4. Okay? Now I can say that 2x equals the square root of plus or minus e to the 1 over 2x plus 16. So x equals a half. Now plus or minus. Now we are only going to accept the minus. Why are we only accepting the minus?
It's a third quadrant.
Yeah, x is in the third quadrant, okay? So that's very cheeky, isn't it? Can we see how...
So what's wrong about this though?
So what's wrong about this? Nothing is wrong about this. This is the same as this. They just want it in this form. Well, actually, they want it x equals... sorry, that's multiplied. X equals minus a half root 16 plus e to the half x. They want, you know, the e there. So that's how they've done it. So they've gone from there to there. It's really good though, because you know that you're going right here. Then double check, you know. Have a look. They want this, we got this. How could they have done that? That working backwards is part of being a fantastic mathematician. Okay, and then part II. Find the value of x2. So what am I going to put into the calculator? Minus 2 equals, and that's going to be my answer, isn't it?
Yeah.
And then I'm going to put in minus a half. Yep. Plus e to the half. Answer. Okay, so it's going to give us minus 2.0228618. However, it wants 4 decimal places. So x2 equals minus 2.0229. And then it wants us to find the x coordinate of P. Okay, so we just keep putting it, we just keep pressing equals now with that as an answer. So for II, we're going to have minus 2.02260628. Perfect.
4 decimal places, miss.
It just wants it to 4 decimal places. So minus 2.0226. And we know we're right as well because our x coordinate should be minus 2 because it's in this quadrant. Okay, so question 10. Figure 4 shows a sketch of part of the curve with this equation. Show that, okay, this equals this. Now, this is going to be 1 plus 2 cos of 2x multiplied by 1 plus 2 cos of 2x. So we're now going to have 1 plus 4 cos 2x plus 4 cos squared 2x. Okay? Yeah. However, it wants it in 4 cos x. Okay, so we know that this one is okay. This one is okay. However, this is not okay. Now, lucky for us, there's a double angle formula that says cos
2x
of 2x equals
2 cos squared x
2 cos squared x minus 1. So this means cos of 2x plus 1, a half equals cos squared x. Okay?
But that's not 4x though, is it?
It doesn't matter. It's not 4x because look at this. This technically, x, this is 2x. This becomes 2 lots of 2x. That's how we get the 4x. Do you see? It might be easier is instead of writing this as x's, our formula, just so that you can see, we can write this in terms of thetas. So in this case, we're going to have our theta is 2x, so it's 2 lots of this. So I'm going to substitute this in. So 1 plus 4 cos 2x plus 4 lots of a half cos 2 theta, which is 4x, plus a half. Okay? So 4 times a half, this all becomes 2. So 1 plus 2 is 3, plus 4 cos 2x plus 2 cos 4x. Okay, therefore, proved.
But like you have to say like Q equals 3, P equals...
Oh, okay, so P equals 3, Q equals 4, R equals 2. Okay? So even though that was 2 marks, I think it's a bit like the maths in it wasn't hard once you spotted that. Yeah? Then it says the curve touches the positive x-axis for the second time. Okay, and it's really important that it says the second time. Because this is our first solution, this is then our second solution.
Yeah.
So we need to find the second solution of this equaling 0. Okay? So when does this equal 0? So for part B, first I need to find the value of A. So I want to find when does 1 plus 2 cos of 2x equal 0. This is when 2 cos of 2x equals negative a half. Okay? Again, whenever we're doing x and y coordinates, we no longer work in degrees, work in radians. So if we find the value of this in radians, we get 2x equals 2 pi over 3. Okay, this is our first solution. Okay, we draw our cast diagram. 2 pi over 3. If we think this is pi, 2 pi over 3 is here, isn't it? Yeah? Now, with cos, we know we reflect in the vertical line. So, this is... so, if we have a look, our first solution, so this would be where we first get 0, is 2 pi over 3. Then, the second solution here would be 2 pi minus 2 pi over 3, which is 4 pi over 3. Okay? So, yeah, this is 4 pi over 3. So, 4 pi over 3 is our second solution. Now I need to divide everything by 2. So, x equals 1 over 3 pi and 2 over 3 pi. So, my second solution is 2 over 3 pi. That must mean A is 2 over 3. So, this is 2 over 3 pi. Okay, so now we found A. We're going to integrate it, and because of part A, it helped us, didn't it? So we're going to integrate between 2 over 3 pi and 0. 3 plus 4 cos 2x plus 2 cos 4x. Okay? So, with respect to x, let's integrate 3. What do we get? 3x. When we integrate cos, we get sine of 2x, and then we need to divide 4 by the differential of the bracket. 4 divided by 2 is 2. Integrate cos again, we get sine of 4x, and then 2 divided by 4 is a half. Between 2 pi over 3, I'll put 23. 2 pi over 3 and 0?
Yeah.
Okay, so let's check this. If I put 2 pi over 3 in this, I get 3 times 2 pi over 3, which is 2 pi, plus 2 lots of 4 pi sine of 4 pi over 3. Okay, plus a half lots of sine of 8 pi over 3. Okay, then I need to take away 3 lots of 0, which is 0.
And sine 0.
Plus 2 lots of, basically this is just 0. Okay, 2 pi is 2 pi.
Yeah.
What is sine of 4 pi over 3? Sine of 4 pi over 3.
Minus root 3 over 2.
Minus root 3 over 2 times 2 minus root 3. Brilliant. Sine of 8 pi over 3?
Root 3 over 2.
Root 3 over 2,
Which is plus root 3.
which is plus root 3.
Oh, so it's still pi.
Ah, so the answer is 2 pi.
Wait, multiplied? Oh, yeah.
Okay, so then, what did we even figure out? The area is 2 pi.
This is root 3 over 2, right? You have
Multiplied by
Okay.
half. No, miss, it's root 3 over 4.
Root 3 over 4.
Yeah.
That's fine. So what's minus root 3 plus root 3 over 4?
It's 5 root 3 over 4.
5.
Oh wait, never mind.
It's minus
Oh wait, it's minus.
3.
Never mind. It's yeah.
Minus
Minus
3
3
root 3 over 4.
Minus 3 root 3 over 4.
Yeah.
Okay. So, therefore, this is the area of the shaded region. Great work, everyone.